All right, so the nice thing about example 3 is it's just giving us more practice with simplifying these expressions. So if we go back over to our note sheet, I'm going to write these out for you guys to see. So we have 32 to the 3/5, which I can rewrite as 32 to the 1/5 cubed. 32 to the 1/5 is 2, and 2 cubed is 8. I will say that usually doing that radicand first, so doing your radical expression first and putting your denominator in the parentheses gives you a smaller number to work with, so that when you do your top number of your fraction, you've got smaller numbers. Now, you'll notice with 27 here, they threw us a little curveball and they gave us that negative. So I am going to put that negative outside with my numerator of my rational exponent. So 27 to the 1/3 is 3, and then 3 to the -2. What does it mean when we have a negative? Negative exponents send our expressions to the bottom of a fraction. We get inverses. And we've talked about negative exponents, so you guys should know that. Now, I love this last one because now they're throwing us an entirely new curveball. We've got 50 to the 3/4. So I'm going to put 50. Sorry, you guys. I know how you hate it when I do that. I'll fix it. 3/4. We're going to put 50 to the 1/4 cubed. Now, if I do my factor tree over here with 50, I get 25 and 2 and 5 and 5. I don't have 4 of anything, which tells me this is going to be gnarly and that I don't want to do it this way. And so now I'm going to show you the cheater way that you can always check your answers or do this. So you can see I already put it in the calculator once for you. But I'll do it again just to show you the steps. So we do 50, and then we hit our caret key, which is our exponent. And then we're going to do our fraction key, which is done by control divide. We put a 3 on top and a 4 on the bottom, and we hit enter, and there it gives it to us. Now, if you wanted to see if it works when we do have a pretty exponent like we've done already, oops, let's clear this. Okay, 32 to the 3/5, which is what we just did. And lo and behold, we get 8 as our answer. So it does work. Now, they've given us a nice little word problem here for part B, which isn't really that bad, you guys. Promise. Okay, so the Fujita scale, or rating F of a tornado, is represented by this expression, where W, this is the important part, they're telling us that W is the wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with wind speeds of 100? So we're going to take that 100 and we're going to put it into our expression. So we're going to say F, our Fujita scale, is going to be the cube root of 100 over 14.1 squared minus 2. This is gross, guys. It's really, really gross, and especially because there's that lovely decimal right there. So guess what we're going to do? We're going to put this in our calculator. Now, to put this in your calculator, I would actually recommend turning this into a rational exponent, like that. So by turning it into a rational exponent, we've just saved ourselves steps on the calculator. So we're going to go back to our calculator. We are going to do our fraction, 100 over 14.1. Then we're going to raise that whole fraction. Oh, I did that again. Sorry, I keep doing that. The whole fraction to the 2/3. And then we're just going to go outside now, and we're going to subtract 2 from the whole thing. Not 22, just 2. And hit enter, and there it is. So our Fujita scale rating for a tornado with 100-mile-per-hour winds is 1.69, or an F1 tornado. Okay, example 4. So example 4 might be a little bit more fun. So if we think about this, we know that that little 5 means that we're looking at our 5th root, right? So what we're actually going to do is we can break this apart. We know that there's a multiplication sign between the 32 and the m. So we're going to do the 5th root of 32 times the 5th root of m to the 15th. Then we know that this is 2. This becomes the numerator. This 15 becomes the numerator in our fraction. The 5 is the denominator. Then you can simplify this fraction, guys. That fraction, what does it simplify into? It simplifies into 3. So this is going to be m cubed. So that is just 2m cubed. Now, what happens if we just have variables and numbers like that? We're going to have x to the 20th, y to the 8th, all to the 1/4. Or, we don't want to do it that way. We want to break it apart first. Oopsie. Went back too far. Sorry. We're going to do the 4th root of x to the 20th times the 4th root of y to the 8th. So we get x to the 20/4, y to the 8/4. So x to the 5th, y squared. Now let's look at, actually I want to go back and look at Pearson and see if they give us any fun things, fun examples with that. That's A, B, no, nothing fun to work with. Okay, we're going to go to x to example 5 now. We're cruising. Woohoo. Okay, x to the 5th. Use nth roots to solve the equations. So we have our 2x to the 5th is 64. Guys, you need to get x by itself. So what are we going to do? We are going to divide both sides by 2. When we divide by 2, these cancel. We get x to the 5th is 32. Now we take x to the 5th to the 1/5. It's going to be 32 to the 1/5. And hopefully after seeing this 16 times today, you know that 32 to the 1/5 is 2. And 5 times 1/5 is x to the 1st, or just x. So x is 2. Now, you should know that since this is a 5th, this is an odd root. We're not going to do anything super crazy with that. We're going to leave it as is. Let's see what we've got, if they've got an extra. They do here. So you'll notice we've got 5x cubed here is 320. So we're going to do x cubed equals 320. Whoops, sorry. 320. Divide both sides by 5. These are not in your notes, so you might want to put this on the other side. That's going to give us 64. And then we take the cube root of both sides. And in this case, x is going to be 4. So hopefully that's enough extra examples that you can see how those equations can be solved.